All right, guys, are there any questions on the assignment so far? Because we've had assignments for 7-1, 7-3-1, and 7-3-2. Okay. What we're looking at today and starting today is addition and subtraction, adding and subtracting rational expressions. When we add or subtract rational expressions with like denominators, we go on and just add or subtract the numerators. The denominators stay the same. So, if we look at the first one here, 7 over 4x plus 3 over 4x would be, well, we can say that it'd be 7 plus 3 over 4x. And 7 plus 3 would be 10 over 4x. Now we can't leave it in this form because there's a what? There's a greatest common factor between 10 and 4. 5 over 2x. Because if there are any like factors, we still need to simplify them just like with multiplication. Any questions on the first one? All right, let's look at the next one. So the denominators are the same, so we could go on and subtract the numerators. So it'd be 2x minus 5 over x plus 6. Now this time we do have x plus 6 in the denominator, so we do need to see if the numerator will factor at all. Well, the numerator 2x minus 5, the degree is 1, and there's not a greatest common factor between the two terms, so there's nothing we can do there. And since there's nothing in common, because this is one whole term, and this is going to be considered one whole term, so this is as simplified as it gets. All right. So for number 1, 8 over 12x minus 5 over 12x, well, the denominators are the same. And we can go on and subtract the numerators. So 8 minus 5 is? And that would be our final answer, yes? No, because 3 and 12 do have a greatest common factor because there are just one term. So we can go on and just simplify that over 4x. 1 over 4x, because the 12 over 3 would simplify because it is an individual term. If it had been x plus 3 in the numerator, we can't simplify it because the x plus 3 would keep those two together. All right, let's look at number 2. Denominators are the same, so we can say we'll have 3x squared on the bottom, and the top would be, okay, which would give us 1 over x squared. Because the 3 over 3 would simplify to 1. Any questions on this here? Let's look at number 4. The denominators are the same, so we would just have x squared plus 1. The numerator would be squared plus 2. And that'd be the answer, yes? No. Is there a greatest common factor in the numerator? Yes, which is a 2. And even if factoring out the greatest common factor or simplifying the numerator didn't do anything, we still need to do it. Because for here, in particular, if we factor out the 2, I'm left with what? X squared plus 1. So do I end up having something in common on top and bottom? So those would cancel out, leaving us with 2. Any questions on this here? Well, unfortunately, not every set of rational expressions will have a denominator that are the exact same. So if the denominators are not the same, we need to make them be the same. And it's really figuring out what's going to make this denominator and this denominator be the same. And once we figure that out, we're going to multiply top and bottom by that so that they are the same. And really what we'll be using is the LCM. If y'all know, remember back to LCM, it is our least common multiple. And the least common multiple is the smallest term or number or expression that we can make these two here be. Essentially what we'll do, and what we do with any of these here, is we grab all the factors of each, we factor them, and take the most that each one has out of both, and that will be our least common multiple. So what we'll do for this here, 4x squared minus 16, and 6x squared minus 24x plus 24. We're trying to see what is the smallest term we can turn both of these into. And the reason we want the smallest one is because anything over than that, anything greater than that, will give us a like term on top and bottom when we start adding and subtracting, which we'd have to pull out later. And it's going to make the problems not harder, but the degree is going to be higher, and it's going to be a little more complicated to work with. Now, if we look at 4x squared minus 16 first, the first thing I would want to look at is a greatest common factor. Is there one between these two terms? 4. Now, it is a difference of perfect squares at the moment, because 4x squared is a perfect square and 16 is a perfect square. But I would still want to factor out the 4 first. And if we do that, 4 out of 4x squared is just going to be our x squared minus 4. Well, x squared minus 4 is still a difference of perfect squares, yes? So how would that factor? X minus 2 and x plus 2. So that there is our 4x squared minus 16 factored all the way down. So the individual terms for it are 4x minus 2 and x plus 2. Let's factor the other one. So 2, yes. 6. Because 2 is a common factor, 3 is a common factor, but 6 is the greatest common factor. And if we factor that out, we're left with x squared minus 4x plus 4. Now we'll need to find the signs. Since the 4 is positive, the signs are the same and they match the sign of the middle term, which is negative. So we'd have a negative and a negative. Now the factors of x squared are x and x. The factors of 4 are 1 and 4 or 2 and 2. 2 and 2 would be the one we want. Okay. Now, we needed both of these factored all the way down as far as they can to be able to find the least common multiple. And when we find the least common multiple, we're looking for what we can turn both of these into. Now, the 4 and 6, I think, are a little more challenging than our parentheses for these binomials. Because what we're wanting with the 4 and 6 is we want the first number that I can turn both 4 and 6 into the same thing. So we can do this in one of two ways. One of them is rewriting these numbers as a prime factorization. The prime factorization is pretty much just all the prime numbers that they can be composed of. So for 6, it's going to be 2 times 3, and that's it. For 4, it's going to be 2 and 2. And what we do for the least common multiples between these two is we take the most of each number that appears. So if we look at 4, 2 appears how many times? For 6, 2 appears once. So for the least common multiple, we're going to take 2 twice from the 4. And then 6 has 3 that appears once. It doesn't appear anywhere for the 4, so we would write it once. Now the other way we can actually do this is, well, I can look at 4 and 6. Well, 4, 6. Well, 4 times 2 is 8. 6 times 2 is 12. If I add 4 again, I get 12. Here I get 18. But the first number that they are both the same is 12. Okay, let's look over here. What is, well, 2 times 2 is 4, times 3 is 12. We can go in either way. So I could look at the multiples of 4 and 6 and just go out a decent way. First number where they're both the same is the least common multiple. Now, I like the sets of parentheses, our binomials, a little bit better with least common multiple, because what I do is I normally just grab one. So this one here has x minus 2 and x minus 2, yes? Well, we'll need both of them. And then I look to the other one and see, what does it have that this one doesn't? Anything else? That's it. Because we can do the exact same thing we did with the 2, 2, and 3. Because if I look to this one here, well, this one has an x minus 2 twice. This one over here has an x minus 2 once, so I will need 2 of them. Okay, that takes care of this entire one here. I look over here, well, this one has an x plus 2 once, so I need it also. And what this least common multiple is, and the reason we want it, is because we're trying to figure out what do I need to do to these two here to make them be the same. So for them to be the same, I need it to be 12 times x minus 2 times x minus 2 times x plus 2, if they're going to be the exact same. And then, well, what do I need to do to this to get here? Well, I do need to multiply it by 2 for the 6 to become 12. And then it's missing a what? The x plus 2. So now it would be the same. Over here, I'm missing in x minus 2, and I would need to multiply this by 3 to get to 12. So this least common multiple helps me figure out what I need to do to make these two be the same. Now this isn't just out of nowhere, because with addition and subtraction we need what? We need the denominators to be the same. That's why we're doing this, to get an idea and feel for it. Once we actually start working with them, it's going to make it a little bit easier than this here. Any other questions on this here? All right. Let's look at the next one. 6x squared minus 54n 9x squared minus 54x plus 81. Well, we can look at the 6x squared minus 54 first. Is there a greatest common factor? 6. Which would leave us with x squared minus 9. Yes, which would be x minus 3 times x plus 3. Now for other one, we will have a greatest common factor of 9, which will leave us with x squared minus 6x plus 9. Now because the 9 is positive, the signs are the same and match the sign of the middle term, which is negative. So negative and negative. Factors of x squared are x and x. And what factors of 9 would we want to use? 3 and 3. Now we need to find the least common multiple, or really find out what I need to do to make these two be the same. And we want the smallest number. Well, we can look at 6 and 9 first. So the two ways we can look at it, one of them is going 6, 12, 18, and looking at 9, 18, 27. Well, 18 is the first number that these both become the same. So the first part of the least common multiple would be 18. Then what can we say next? So we're looking at these two here, yes? So I know I need an x minus 3 at least once, yes? How many times do I need it? Twice, yes. I wouldn't say 3 because here it appears twice. Here it does appear once, yes? But the most that it occurs in either one is twice. So if I add an x minus 3 here, do both of them have the same amount? So I need only 2 for them to be the same. Even though it does show up 3 times, we only need it twice. Anything else missing? X plus 3. Because we would need it here, and then we would just need to change the 9 and 6 so that they are both 18 for them to be able to be the same. And that's it. Questions on this here? We ready for the next one? Find the least common multiple of 5x cubed and 10x squared minus 15x. So we can start out with 5x cubed first. What can we do with it to factor it? Can we do anything? No. It's one term, it's by itself, so we can't do anything to it. How about the 10x squared minus 15x? So we can factor what out? And? X, because they both have an x. 5 factored out of 10 would be 2, and x factored out of x squared is x minus 3. And the x should factor out completely. Okay. Least common multiple. So we're not too focused on this part here. We're more focused on this one and this one, yes? So looking at these two, we need to get the 5 to be the same as 5. So, well, that would just be 5. Because they are already the same. 5 and 5 are already the same. Next to the 5, we have what? X. And over here we have x to the third. So the least common multiple would be x to the third. Because if one of them has 3, we need the other to have 3 for them to be the same. Anything else? there's one last thing. 2x minus 3. And that there would be the least common multiple. Any questions on this here? All right. So we're going to use this using addition and subtraction. Now, as we can see, the denominators for these two are definitely not the same. So, yes, they could be, and we're going to make them be the same. Now, we're not going to do anything with the numerators yet. So the 7 and the x are just going to stay the same. What we want to do first is to factor the denominators as far as we can. Well, 9x squared is going to stay the same because it's only a single term. What can we do with the 3x squared and 3x? We can factor 3x out. We can divide each term by 3x. So we'd have 3x times x plus 1. So we can look at the least common multiple, but the big piece here is that we need the denominators to be the same. So here we have 9x squared, and the other we have 3x times x plus 1. So one of them I do have a 9, the other I have a 3 up front, yes? So what do I need to do to the 3 to make it be the same as 9? So I need to multiply this by 3, yes? Okay. And whatever I do to the denominator, I'm going to have to do to the numerator. What else do I need to do to this 3x to get it the same as 9x squared? So what else do we need to do to the 3x to make it the same as 9x squared? So we need the x to become x squared, yes? How can I change x into x squared? Multiply it by x. Do I need to do anything else to the 3x times x plus 1 to make it be similar to the 9x squared? No, because that would give us 9x squared, yes? Okay. Is there anything I need to do to the 9x squared to make it the same as our 3x times x plus 1? This one over here is missing the x plus 1, yes? So I'm going to have to multiply top and bottom by x plus 1. Now this multiplication of x plus 1 and x plus 1 on the one side and 3x over 3x on the other is quite helpful. Because realistically, what are we multiplying both of these by? Because what is 3x divided by 3x? X plus 1 divided by x plus 1 is? So are we really changing these? No. It's a fancy version of 1. And what this does, now let's go on and multiply them together. So for this one over here, well, we would have 9x squared times x plus 1. Our other one is going to be 3x times 3x, which is going to be 9x squared times x plus 1. Now with the denominators, we're going to leave them in factored form. We're going to leave them alone in factored form. As we saw with the one earlier where we ended up having that x squared plus 1 over x squared plus 1 and we could factor it out, simplify it down, that's why we want these to be simplified. We want them factored. We don't want to multiply them together. Unfortunately, the numerators, we are going to have to multiply them out. Because of the addition in the middle, we'll have to combine our like terms. So on top, well, we have x plus 1 times 7. Now with this here, we can go on and multiply out. X times 7 is plus 7. 1 times 7 would give us 7. Over here, we're going to have x times 3x, which is 3x squared. And last but not least, we can add the numerators because the denominators are the same. So we'll have 3x squared plus 7x plus 7. Now we would need to check to make sure that the numerator is not factorable in any way, and this one's not. Because we can go back to the b squared minus 4ac, the square root of it, which would be 7 squared minus 4 times 3 times 7, and type that into a calculator. And we could do it with the square root. Because if this does give us a whole number, it means it's factorable. If it gives us a decimal, a term with I, a decimal, a term with I, it doesn't work. Well, here we would have 49 minus 4 times 3 is 12, times 7 is, I think, 84. 21, 80, you know, which would give us the square root of negative 35. That's not a real number. So that tells us that that's not factorable. There's no greatest common factor. That's our answer. Any questions on this here? We ready for the next one? Is there anything we can do to the 12x squared to factor it? I mean, not by itself. There is a greatest common factor between the 8 and 12. 4. And we can simplify that here. Yeah. So that would be 2 over 3x squared. Can we do anything with the x squared plus x? We can factor an x out, which would leave us with x plus 1. Any questions on this here so far? Now we could simplify the x over x in the other rational expression, but in the end it's actually not going to do a whole lot. Because if I simplify this here, I would get 1 over, well, or scroll back up, 1 over x plus 1. Now, we're going to need to multiply both sides by something to get them to be the exact same. So we will need to multiply this one by 3x over 3x almost. It would be 3x squared, because it works out that the entire one on the left's denominator is completely missing from the one on the right. And it actually works out that the one on the right is completely missing from the one on the left. So we would need 1 and x plus 1. now all we have to do is multiply the numerators and denominators with these here. Okay. So for the one on the left here, when we multiply the 2 by the two terms, 2 times x would be plus 2. The denominator is going to be 3x squared times x plus 1, because again, we don't want to multiply those together. Because if it does work out that there is a common factor, either as a set of parentheses or just a constant term or a variable, we need it factored down. So we could multiply it together, but then we'd have to factor it right back out. Now for the other one, well, 1 times 3x squared is 3x squared over 3x squared times x plus 1. And last but not least, we need to add them together, which would give us 2 over times, and this here is going to be final answer, because 3x squared plus 2x plus 2 is not going to be factorable at all, because we'd have to be looking for multiples of 3 and 2 that would somehow manage to get back to 2. The only way that would work is if we had some type of subtraction possibly, so the 2 would have to be negative. Any other questions on this here? Using subtraction with unlike denominators. Today. Because I think we have a few more problems with this here. All right. Let's look at these here. Now the numerators are not going to change. But we can factor the denominators. So if we look at the 2x minus 2, what can we do with it? We can factor out the 2, which will leave us with x minus 1. And that's all we can do for that one there. Now for the other one, x squared minus 4x plus 3. Since the 3 is positive, it means the signs are the same and match the sign of the middle term, which would be negative and negative. Now the factors of x squared are x and x, and then we would have 3 and 1. And that would be those two factors. Now we do need to get these to be the exact same. So we're going to multiply top and bottom, so we get the denominators to be the same. So for the first one, we need x minus 3 to get them to be the same. So I will multiply top and bottom by x minus 3. Now the one on the right is missing a 2 on bottom for those to be the exact same. So we can multiply top and bottom by 2. Now the denominators for both of these will end up being 2 times x minus 1 times x minus 3. And that would actually be our least common multiple. Now for our numerator on the first one, we're going to have to distribute these out. X minus 3 times x plus 2. So we'll do x times x, which is squared. X times 2 will be plus 2x. Negative 3 times x would be minus 3x. And negative 3 times 2 is negative 6. Over here, we're going to distribute the 2. So 2 times negative 2x is negative 4x. 2 times negative 1 is negative 2. Any questions on any of this here? Now at this point here, we can combine like terms on either one of these here. Well, mainly just the first, which would give us x squared minus x minus 6 over R2 times x minus 1 times x minus 3. Well, now do we have the denominators the exact same? Yes. So that means for us, we can subtract the numerators. Now for our first one, nothing's really going to change. But the second one, we are subtracting what? Our negative 4x minus 2. And when we have this subtraction with negatives, it's going to affect the signs. So the x squared minus x minus 6 isn't going to change. But the negative in negative 4x is going to make it plus 4x. Our negative in negative 2 is going to make it positive 2. And now we can actually combine like terms. The x squared is going to stay the same because it's the only one. Our negative x plus 4x is going to be plus 3x. And negative 6 plus 2 is negative 4 over 2 times x minus 1 times x minus 3. Well, this one here, it does look like we can factor that numerator. So for this here, we would have 2 sets of parentheses with 3 spaces. Now, since the 4 is negative, our signs are going to be opposite. Factors of x squared are x and the factors of 4 are 4 and 1 are 2 and 2. Which one do we want to use? Which one would be positive and which one negative? Negative 1 and positive 4. And these here would actually be the factors. Well, actually, do we have something in common on top and bottom? Yes, we have the x minus 1 and x minus 1, so they would actually cancel out. Should have dropped 1 lower before I went across. Which leaves us with x plus 4 on top over 2 times x minus 3. So that there is why we leave the bottom, the denominator factored, just in case there is a common factor on top and bottom that would simplify out. Because if we had gone on and multiplied the denominator together, we would have had to factor it back out to find that like terms on top and bottom. Any other questions on this here? We'll save this for tomorrow.